This video is specifically designed for Algebra 2 Honors. If you are not an Algebra 2 Honors student and you still want to watch the video, this is just another way to simplify radicals. Okay, so for those of you that are in Honors, this is what we are going to do in class. This is how we're going to learn it. For those of you that aren't Honors, you did it a different way, but you can still watch this and learn a different way too. Maybe makes more sense, I'm not sure. So in this video, what we're going to do is simplify radicals, square roots. Okay, simplifying means I'm not just going to put it in a calculator and get a decimal value of square root of 200 or square root of 74. I'm going to break it down so that it is the exact value, not an approximation. Okay? So when I simplify square roots, here is one way to do it. What I am going to do is first understand what a square root is. So remember, a square root is a number times the same number. So think of it as a times a. Okay? And a could be anything. 3 times 3, 4 times 4, 15.2, 73.3. It could be anything. When I take the square root of whatever a times a is, I'm always going to get a. So if a was 3 times 3, that's 9. So then the square root of 9 is 3, just like I did it. Okay? Because 3 times 3 is 9, square root of 9 is 3. Now, what does that actually mean? Okay, so when I have a perfect square, 9, that means that I'm going to get an integer value, a whole integer value, not a negative, because we can't have square roots as to be negative numbers. We can, well, I guess we can, but we'll talk about that later. So perfect squares will always come out as integers. Okay, so what I'm going to do is we are going to write down all of the perfect squares up through, say, 15. Okay, and if you need more, then you can have more than that. But let's just go to 15. So perfect squares. So 1 squared is 1, right? 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And we're going to keep on going. I go back up to 15. So 6 squared is 36. 7 squared is 49. 8 squared is 64. Okay, hopefully you're still with me. 9 squared is 81. 10 squared is 100. Those should probably be memorized up through at least 100, I mean 10 squared. Now gets the harder ones because the numbers start getting larger. So 11 squared is 121. 12 squared is 144. Again, those might be memorized as well, but now comes ones that we probably don't know. 13 squared is 169. 14 squared is 196. And 15 squared is 225. Now, the more you use them, the more you're actually going to memorize them. Okay, you can go 16, 17, 18, 19, 20, and up through 25, 30, 30, whatever. Okay, you don't have to memorize all of them because you're going to have a calculator to do so. And I'll give you a sheet of paper as well during class. We'll have all the ones up through, say, 20 on there, up to 20 squared, up to 400. So in this particular example, is I want to use the square root of 200, and I want to break it down so that it contains the biggest perfect square that can fit into it. Okay, what I mean by that is this. So we know that the square root of 200 is also 4 times 50. Okay, 4 is a perfect square. 4 appears inside there, but it also appears here, so that's good. But I want to find the biggest one. Okay, so I'm going to look. 9 doesn't go into 200. 16 doesn't go into 200. 25 does go into 200. So 25 times 8. Again, 25 appears. 36 doesn't go into it. 49 doesn't go into it. 64 doesn't go into it. 81 doesn't. And 100. So the only perfect squares that go into 200 are 450, 25 and 8, and 102. Well, what is the biggest perfect square that goes into 200? Well, that's 100. right here. So what I'm going to do is I am going to take the square root of 100 and the square root of 2. Square roots can break it down this way. We'll get more into square roots later on, but this right now is what we're going to be doing. So square root of 100 times the square root of 2 is the same as square root of 100 times 2. Well, what's the square root of 100? 10. Is there a square root of 2 that I can break that down? No, there is not. So it's the square root of 2. So the answer is 10 square root of 2 as the answer to this problem. Always want to find the biggest square that goes into the number. It just makes your life easier. So let's look at this next problem. Square root of 70. So let's see if we can find a perfect square that goes into 70 other than just 1, really, because 1 doesn't really matter. Well, 70 is not divisible by 4. It's not divisible by 9. It's not divisible by 16. It's not divisible by 25 or 36 or 49 or 64 or 81. How do I know when to stop? When the squares are bigger than the number that I care about. So where can I stop on this one? I can stop right there because 81 is bigger than 70, so I know that 81 can't go into it. Evenly, anyway. So, because I don't have a perfect square in square root of 70, then my answer is just square root of 70. If I can't simplify it, then the number that is the answer is just what's left inside. So 70 cannot be reduced, so 70 is my answer. Square root of negative 63. I said 2 problems ago that we can't have a negative inside a square root. Technically that's true in terms of real numbers. Like, it's not a real number if I have a negative inside, because a negative number times a negative number will always give me a positive number. No number times itself will give me a negative. But remember, we talked about complex numbers and i's and all that stuff. So the square root of negative 63 is actually broken down into the square root of negative 1 times 63. Then I want to look at the 63 and see what's the biggest perfect square that can go into it. So I'm going to rewrite this a little bit. I got the negative 1 here. And 63 is actually, you got 21 times 3, but that's not a perfect square. You got 9 times 7. And 9 is the biggest perfect square that can go into 63. So what happens is I have negative 1 square rooted, I have square root of 9 and the square root of 7 all being multiplied together. I can break up square roots this way. Again, we'll get to that later on and why we can do that, but for right now, this is okay to write it. Now I look at each individual term. We said when we talked about complex numbers that the square root of a negative 1 is always an I. The square root of 9 is 3, and the square root of 7 is just the square root of 7. Can't do anything with it, mainly because it's prime, but for the most part I can't do anything with it because it's not a perfect square. So, how do I write my answer? Well, 3i, usually the number comes first, right? The I goes second. And then our radical 7. That is the answer to this problem. This one on the board. So again, I want to break down 48 to get to the biggest perfect square. So here are some perfect squares. 4 times 12. 4 is a perfect square, 12 is not, but 4 goes into it, so that would work. Okay? The next one, 9 can't go into it. 16 can. Okay, 16 times 3. 25 can't go in. 36 can't go in, and then I'm now bigger, 49, so I know when to stop. Because I said the biggest one, we know we're going to use this one. So that's the square root of 16 times the square root of 3. Remember, we said we can do that. And then square root of 16 is 4. Square root of 3 is just the square root of 3. So this is my answer for this one. Okay, let's look at this one here. Again, I want to find the biggest perfect square that can go into it. Well, technically, yes, you have 1 times 8. Then 2 is not a perfect square. Well, 4 is 4 times 2. And that's the biggest one because 9 is now over 8, so now I'm done. So which one's the biggest? Well, that one there, of course. Square root of 4 times the square root of 2, because we said we can. So that's 2 square root of 2. Let's look at this last and final problem for simplifying square roots using perfect squares. 810 square rooted. Let's find the biggest perfect square that goes into it. So let's start here. Square root of 1 times 810, right? 1 times all of that can go in, so 1 can always go into it. Maybe that works, maybe it doesn't. Well, it all depends. Let's look at the next one. Can 4 go into 810? It cannot, okay? So again, use your calculator to identify which ones that can go into it. Can 9 go into 810? Yes, it can. 9 times 90 is 810. What about 16? That cannot go into it either. What about 25? That cannot go into it either. What about 36? That cannot go in either. What about 49? Nope. What about 64? Nope. What about 81? That is true. 81 times 10. And then 121 can't. 144 can't. 169 can't. 196 can't. 225 can't. And then if you wanted to keep going 16, 17, 18, that would be 256. That's a no. 289. That's a no. 326. That's a no. 361. That's a no. 400. That's a no. That's all up to 20 squared. Okay? So if we actually go up through all of it, this is the biggest perfect square that can go into it. So that's the square root of 81 times the square root of 10. Again, we can do that. And that's 9 square root of 10. This concludes the simplifying square roots and into exact values, right? Not just approximated values as decimals. So concludes the square root video for my honors class. Again, if you are not in honors, this is just another way to do it. And if you are in my honors class and you think this is maybe a difficult way, then check out the next video, and that will be a different way how to do it. It might take a little longer, but it's just another way to do it.